Good morning, students. Today we will discuss about the Bessel's function. As we have done the series solutions of differential equations by power series method and Frobenius method, now we will discuss about the Bessel's function. Now the differential equation of the form d2y by dx square plus 1 by x dy by dx plus 1 minus n square upon x square y is equals to 0. This is our Bessel's differential equation. And when we multiply it with x square, it becomes x square d2y by dx square plus x dy by dx plus x square minus n square y is equals to 0. Where n is any non-negative real number. Keep in your mind, n is non-negative real number. It is known as Bessel's equation of order n. As we have already done in case 1 of Frobenius method, that we have there solved the Bessel's differential equation of order n. It is a Bessel's differential equation of order. You have to keep in mind the statement of the Bessel's equation, that is x square d2y by dx square plus x dy by dx plus x square minus n square y is equals to 0. The solution of equation 1 or 2 is known as the Bessel's function. So what is Bessel's function? Solution of Bessel's equation of order n is called the Bessel's function. Here 0 is a regular singular point of 1 or 2. You know, here we have proved in example that 0 is a regular singular point of equation 1, whether it is 1 or it is 2. So you know how to find the ordinary and singular points when we will check it. Here 0 is a regular singular point of the Bessel's equation. Now we have already solved the Bessel's differential equation of order n in case 1 of Frobenius method, which is called the Bessel's function. Now solution of Bessel's differential equation. We have already solved Bessel's equation by Frobenius method and got two independent solutions as well. We have got these solutions. We give it name 3 and 4. You know, in case 1 of Frobenius method, we got these two independent solution in case 1 where 2n is non-integer. So it is for non-integer. We get the two solution. We give it name AUX and BVX. Case 1. Now we are given n is non-negative real number. So it can be integer. If n is a non-integer. Now case 1 we are discussing about the if n is non-integer. Then solution is AUX plus BVX, where A and B are arbitrary constants. You know that when n is non-integer, roots are differ by non-integer, we got the solution AUX plus BVX that we got in equation 3rd and 4th. Now if n is 0, you know if n is 0, the Bessel's equation of become of order 0. So we put n 0 here, we get this equation which becomes, when we will cancel out x, it becomes x d2y by dx square plus dy by dx plus xy is equals to 0. This is a Bessel's equation of order 0. And in case 2 of Frobenius method, we have find the solution of Bessel's equation of order 0, that is AUX and BVX. These are the solutions. We give it name 6 and 7. So what was the general solution there? AUX plus BVX. So case 1 and 2 we have already discussed in Frobenius method. Now what is case 3? Case 3 is that if n is an integer. Now we are discussing about if n is an integer. We have done case 3 and 4 in Frobenius method where roots are differ by integer. But they were different because there was we have taken Hermite's differential equation and so on, and Bessel's equation of order 1 also we have discussed here. But there was some coefficients become indeterminate and some coefficients become infinite. But now we are discussing if n is an integer. Now see, if n is an integer, n can be positive or n can be negative. If n is positive integer, equation 4th does not gives Vx. Why so? Because what is equation 4? If n is positive integer, if you will put n 1, 2, 3 and so on, any term, this becomes infinity. So equation 4th will not gives Vx. So we will get only Ux. Similarly, if n is negative, equation 3rd does not gives Ux, because if n is negative, it becomes infinity. So if n is positive, we don't get Vx, and if n is negative, we don't get Ux. So if n is an integer, we get only one solution, that is Ux. We have taken Ux because we are discussing about the non-negative real number. So we have taken Ux. So, but we have to find two solutions, two independent solutions. So other independent solution of Bessel's equation will be obtained as below. How we will find it? We will find it by that suppose y is equals to fx ux be a second solution of 2. So where fx is to be obtained. So we have to find the fx here. So we will find dy by dx. What will be dy by dx? That is f dash x ux plus fx u dash x. Now we will find d2y by dx square, it will be f double dash x, this is, and put all these value in equation 2. In this equation 2, that we in this equation 2 you will get this. Now when you will put it there, you will get the, you will solve it and you will find fx common from one bracket, and this is the term. Now you see, you know that we have assumed ux is a solution of Bessel's differential equation. So when we will put ux in the Bessel's equation, it becomes 0. What was the Bessel's equation? X square d2y by dx square means u double dash x, u dash x plus x square minus n square ux is equals to 0. So this is the term, so it becomes 0. So we are left with only these terms. Here should be x square, f double dash x, and this is the term. Divided by x square, here should be also x square, f dash x ux. And thus you will get this term. Integrating, here it becomes derivative of upon this, so log f dash x, 2 log ux plus log x is equals to log c. When you will take log term together, you will get f dash x ux, x is equals to c. And what will be f dash x is this. So again you will get fx by integrating this. Now what was the, we have taken y is equal to fx into ux. We have put the value of fx here. But here when you will put the, this is a term, you will take c outside, so y is this. But we want to find the vx. Now ux is already there, so we will take this c dash become c dash, we will take it to 0. So we have taken Vx C dash 0, so this is the answer. So final solution will be A Ux plus B dash Vx. This is Vx. And because if we will take not C dash 0, Ux becomes, here Ux become, will come two times. So we have omitted here, we have taken C dash 0. Aux plus B dash, we have put the value of Vx, and this is the solution for other independent solution when n is an positive integer. Okay class, now come to the Bessel's function that we are doing. Now equation third, you know that it is the Bessel's equation of order n we have done, where n is any non-negative real number. Now equation, here a node is any real. Here node we have taken, what is equation third? Equation third is the solution. We have taken only ux here because we are talking about the non-negative, so we are not taking vx. So we are taking ux only. Here we have taken a node is, we have assumed it. You have to keep it in your mind that a node is this 1 upon 2 raised to power n gamma n plus 1. Now what is gamma? You know the definition of gamma n, that is 0 to infinity e raised to power minus t, t n minus 1 dt is known as the gamma function. This is the gamma n. This is the known as the gamma function. Now what is ux? Now we will put the value of a node here 1 upon 2n gamma n plus 1 xn, and this is the equation third. You will write it in the summation form, that is k0 to infinity minus 1 raised to power k, x raised to power 2k, 2 raised to power 2k, factorial k, n plus 1, n plus 2 up to n plus k. You can write it in summation form. After that, you will take this term inside, x raised to power n plus 2k, factorial k, gamma n plus 1, n plus 1, n plus 2 up to n plus k. Now we know the property of gamma function, that gamma n plus 1 is written as n gamma n for any non-negative real number. But if it is non-negative integer, we can write gamma n plus 1 to factorial n. So gamma n plus 1, we have taken this term, gamma n plus 1, n plus 2, n plus 2, n plus k. Now this become n plus 1. We have taken n plus 1 and gamma n plus 1 together. It can be written as gamma n plus 2. Similarly, again we will take these terms together, it becomes gamma n plus 3, and so on. In the last you will get gamma n plus k into n plus k, which will become gamma n plus k plus 1. So in the place of this term, you can write gamma n plus k plus 1, which we have write here. Ux is what? Summation k is from 0 to infinity minus 1 raised to power k, x raised to power n plus 2k, 2 raised to power n plus 2k, factorial k, gamma n plus k plus 1. This is a particular solution of 2. It is called the Bessel's function of first kind. It is known as Bessel function of first kind of order n. Why order n? Because we are solving the Bessel's equation of order n. And it is denoted by Jnx. Keep it in mind, Jnx. What is Jnx? We have to learn the statement, learn the solution, that is k0 to infinity minus 1 raised to power k, x upon 2. We have taken it together, n plus 2k, 1 upon factorial k, gamma n plus k plus 1. We are doing it for non-negative real. If n is non-negative integer, in place of gamma n plus k plus 1, we can write factorial n plus k. Because for gamma n plus 1, it is factorial n for non-negative integer. So in place of here, we can write it factorial n plus k. So this is Jnx. You can learn it this also, and you can learn it this also. Also we have equation 4. Now equation 4 will give Bessel's function of first kind of order minus n. You know that we have two roots, c, n is n minus n. So equation 4th will give, we will just change all the term into minus n. So it will get j minus nx. It is called Bessel function of first kind of order minus n. So if n is non-integer and non-negative real number, non-integer because we are doing all it for non-integer. Only if it is integer, we will get only ux, because vx will not give the answer because it becomes infinity. But if n is non-integer and non-negative real, we can find the first kind of order minus n. So we get two independent solutions, jnx and j minus nx. So last answer will be a jnx plus b j minus nx, and this is the answer. So we get Bessel function of first kind of order n from ux and Bessel function of second kind of order minus n from vx. So last solution is this. This is for non-negative real. If it is non-negative integer, we will get only ux, and that is jnx. Okay class, thanks a lot.